In this video, we're going to look at gases' relationship using pressure and volume. And anytime you're looking at the relationship of gases, pressure and volume, this is called Boyle's law. And essentially, the pressure of a given amount of gas is indirectly, so this is very important that we notice this, it says is indirectly proportional to its volume when the temperature and the number of moles is held constant. And how we show that in written form is just the pressure is indirectly proportional, and that's how we write the indirectly is writing 1 over the volume. We can write this mathematically by putting in an expression here of pressure equals the proportionality constant times 1 over volume. And if we have a gas that's confined for its temperature and number of moles and N, then we can write an equation where we solve for K, where the pressure times the volume equals that proportionality constant as you see here. And so what that means is that anytime the pressure of some gas would move up, then for that proportionality constant to still be the product of those two, then the volume would need to go down. And so if we look at that in two conditions, so condition number 1, the pressure and the volume, multiply those together, you get the product of that, and you get the proportionality constant. And if you look at that same gas in a second condition, that would be the pressure 2 and the volume 2, and you multiply those together, you should still get the same K. And so if both of these are equal to K, then we should again be able to set those equal to one another, and that gives us this equation here. And this is called Boyle's law. Let's use this equation to solve our problem. It says a sample of gas has a volume of 30.0 milliliters at a pressure of 6.5 psi. That means 30.0 milliliters and 6.5 psi are condition number 1. Then it says determine the volume of a gas at a pressure of 11.0 psi. That volume unknown and pressure are our condition number 2. So let's write these out. We have pressure 1, volume 1. Pressure 1 is 6.5 psi. Volume 1, 30.0 milliliters. And then pressure 2, we know to be 11.0 psi, but the volume 2 is unknown. Now, there should be no reason, given the fact of our type of equation, the way that it is set up, for us to change any of the units of pressure and volume. The only time that you need to monitor units for either pressure, volume, temperature, or number of moles is in doing any kind of conversion for those in these kinds of condition changing situations is whenever you're using temperature. So remember, every time you use a gas law equation, you're always going to use temperature in Kelvin. So we don't have that in this particular equation, so we don't have to do that. So let's look at putting all of these guys into our equation and solving for our unknowns. We'll put 6.5 psi times our volume of 30.0 milliliters, and that equals our pressure of 11.0 psi times V2. And we'll solve for V2 by dividing both sides by 11.0 psi. The PSI cancels along with the 11 on the right-hand side. The PSI cancels on the left-hand side, and this leaves us in the units of milliliters. And we get a volume 2 to be, in my calculator, I get like 17.7 milliliters, but we need this to be to 2 sig figs. So I'm going to use that 7 to round the previous 7, and I'm going to have 18 milliliters is the volume of our gas at 11 psi. So in this video, we've looked at the relationship between pressure and volume. We call this Boyle's law, and this is the equation you should use anytime you're looking at that relationship.